Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss oxoacids of halogens. Last class I have discussed hydrogen chloride. Now I am going to discuss oxoacids of halogens. Due to high electronegativity and a small size, fluorine forms only one oxoacid, HOF, known as fluoric acid. Fluoric, F-L-U-O-R-I-C, fluoric acid. Oxidation state is 1, also called hypofluorous acid. The other halogens form several oxoacids. Most of them cannot be isolated in pure state. They are stable only in aqueous solution or in the form of their salts. The oxoacids of halogens I will tell in little details, and their structure also I will tell. This halic acid, now I am telling details of oxoacids of halogens. Halic acid 1 means oxidation state 1, halic 1 acid, and after that halic third acid means oxidation state 3, halic fifth acid means oxidation state 5th, and halic acid 7th means oxidation state 7. Halic acid 1 is also called hypohalous acid. HOF is called hypofluorous acid. HOCl, it is called hypochlorous acid. HOBr, it is called hypobromous acid. HOI, it is called hypoiodous acid. Halic acid third, in that only chlorine have this third. Actually chlorine have third, fifth and 7th. Then HOClO, that is called chlorous acid. HOClO. Here chlorine has 3 oxidation state, and next is chloric acid. Here chlorine has 5th oxidation state, 5 oxidation state, HOClO2, total 3 oxygen. In chlorous acid 2 oxygen was there. Here 3 oxygen is there in chloric acid, oxidation state 5. And next is perchloric acid. Here total number of oxygen is 4, HOClO3. Perchloric acid. Here chlorine has 7 oxidation state. Perchloric acid. Then total 4. I told you. First oxidation state 1, hypochlorous acid. When oxidation number is 3, then it is chlorous acid, HOClO, 2 oxygen. Now Now third one, HOClO2, 3 oxygen. This is called chloric acid. Oxidation state is 5. And last is HOClO3, that is the perchloric acid. Oxidation state is 7. Now HOBr, bromine, related to bromine, oxyacid of bromine, I am telling you. Hypobromous acid, HOBr, hypobromous acid, hypobromous acid. Here bromine has +1 oxidation state. After that, there is no third, direct fifth, HOBrO2, 3 oxygen, but oxidation state is 5. Bromine has 5 plus 5 oxidation state, and name is bromic acid. Just like chloric acid, it is bromic acid. Okay, HOBrO2. And perbromic acid, same way, just like perchloric acid, perbromic acid, HOBrO3. HOBrO3, oxidation state is +7, perbromic acid. Now related to iodine, oxoacid of iodine. Then here oxidation state 1, that is the hypoiodous acid. Hypoiodous acid. Here iodine has +1 oxidation state. Hypoiodous acid. Now no third, direct fifth is there, oxidation state +5. HOIO2, 3 oxygen, HOIO2, and it is called iodic acid. Iodic acid, +5 oxidation state. And here also periodic acid is there, 3 oxygen, but oxidation state is +7, HOIO3. HOIO3, this is called periodic acid. Now come to the structure. Hypochlorous acid. Structure of hypochlorous acid, I am telling you, where chlorine has +1 oxidation state. Then here that oxygen is in the middle, and down one side H, other side Cl is there. Okay, it is just like reverse of V. What you are writing V just reverse way. Shape is O in the middle, and down left side down H is there, and right side Cl is there. Okay, O and H single bond, and O and Cl single bond. Total 3 atoms, HOCl. This is called hypochlorous acid. Now come to the chlorous acid. Chlorous, that was the hypochlorous. Now it is only chlorous. That is the +3 oxidation state. Means here chlorine is +3 oxidation state. Means obviously it will make 3 bond. Total 3 bond it can make. But here 2 bond, double bond is with 1 oxygen, Cl and O, double bond, and 1 bond is with other oxygen, ClO, and with O is oxygen, this -2 oxidation state. Then now 1 oxygen is making with Cl, 1 bond, and other bond is with H. Then it became, its structure is again similar to hypochlorous acid. just like HOCl. It is same way, just like reverse of V, hypochlorous, and HOCl, same way, but addition to this Cl and O, because here two oxygen is there, then Cl and O is making double bond. Okay, then this is called chlorous acid, and its oxidation state is +3. Cl has +3 oxidation state. Now come to the chloric acid, chloric. Then here oxidation state of Cl is 5. It means it can make 5 bond. But here 3 oxygen is there in chloric acid, 3 oxygen. Then with 2 oxygen double bond it is making, and 1 bond with oxygen, one bond with oxygen. Then now oxygen has managed to, it can make 2 bond, then 1 oxygen. Now other bond it is making with H, because HOClO2. Then Cl made 3 oxygen is there, then with 2 oxygen double bond 4, and with 1 oxygen single bond, and oxygen has 2 negative, these things 2 valency, negative -2, then 1 is attached with Cl and other is attached with H, means O and H single bond. This is called chloric acid. Now perchloric acid, then here oxidation state is 7. Chlorine has +7 oxidation state. Then here total number of oxygen is 4, HOClO3. Then now 7, it can make 7 bond, then 3 with 3 oxygen double bond. Then now 6 is over, and 1 is with oxygen. 1 is with oxygen, means chlorine is making bond, double bond with 3 oxygen and single bond with 4th oxygen, and 4th oxygen is making single bond with H. This is called perchloric acid. And same way this oxoacid of bromine. Okay, same way it can make HOBRO2 and HOBRO3, means here bromous acid is not there. Bromic acid is there, means +5 and +7 oxidation state is there. +3 is not there. Then it's a structure, and oxoacid of iodine have same type of structure. Now I am discussing about interhalogen compounds. Interhalogen compounds, many question is asked from interhalogen compounds. Already I told you interhalogen compounds means these elements, members of halogen, they themselves will make compound. And here that this more electronegative will behave as a electronegative, and less electronegative will behave as a electropositive. Okay, both are negative, but which is less, that will behave as a electropositive, and which is more negative will behave as a negative. Then cation and anion, like that it will form. Less will behave as a cation and more negative will behave as a anion, and they will form interhalogen compound. When two different halogen react with each other, interhalogen compounds are formed. They can be assigned general composition as X X dash X X dash. Okay, then one type of compound they will form X X dash. One is cation, other is anion, X X dash. Second is X X dash 3, X X dash 3. Next is X X dash 5, means X dash is 3 atom, and here X dash X5, X dash is 5 atoms, and X dash 7, where X is a halogen of larger size and X dash of a smaller size. X is larger size and X dash is a smaller size, and X is more electropositive than X dash. Already told you, one will behave as a electropositive, other will behave as a electronegative. As the ratio between radii of radius of X and X dash increases, the number of atoms per molecule also increases. Thus, iodine 7 fluoride, means IF7, should have maximum number of atoms, as the ratio of radii between iodine and fluorine should be maximum. Radius ratio of radius between I and F is maximum. That's why maximum number of atom will be there in IF7. Okay, iodine 7 fluoride should have maximum number of atoms, as the ratio of radii between I and F, because the ratio of radii between I and F should be maximum. That is why its formula is IF7, having maximum number of atoms. Now I want to tell about preparation of interhalogen compounds. The interhalogen compounds can be prepared by the direct combination or by the action of halogen on lower interhalogen compounds. Again, I am telling you, interhalogen compounds can be prepared by the direct combination or by the action of halogen on lower interhalogen compounds. The product formed depends upon some specific conditions. Reaction I am telling you, Cl2 plus F2. Cl2 you are adding first and then fluorine F2. Why? Because chlorine is less electronegative than fluorine. Then chlorine will function as electropositive. Fluorine, which is more electronegative, will behave as electronegative. Then equal volume of both Cl2 plus F2 at 437 Kelvin, it will form 2ClF. ClF. First you are adding Cl, then you are adding F. This way, this chlorine plus fluorine. If fluorine is excess, in excess, now it was equal Cl2 plus F2. It formed 2ClF. Then equal volume. Now fluorine is in excess, Cl2 plus 3F2. At 573 Kelvin, it will form ClF3, chlorine trifluoride. and this ClF was chlorine fluoride. Now again same way I2 plus Cl2, I2 plus Cl2. Now iodine, that is a we can say in comparison to Cl2, I2 is less electronegative and Cl2 is more. Then it will form 2ICl. Equimolar volume you have taken I2 plus Cl2, 2ICl. First you are adding I, then Cl. Now reason you are understanding, I is less electronegative than Cl. Similarly, now I2 plus 3Cl2. Now Cl2 is in excess. Cl2 is in excess. Then I2 plus 3Cl2. It will form 2ICl3, iodine trichloride. And Br2 plus 3F2. Br2 plus 3F2. Both should be diluted with water. Okay, diluted with water. Then Br2 plus 3F2. It will form 2BrF3. Again we can see here BrF3, bromine trifluoride. Always less electronegative you are adding first, then more, then BrF3. Now one more reaction I am telling you, Br2 plus 5F2, excess. Fluorine is in excess. Then Br2 plus 5F2, it will form BrF5, bromine pentafluoride. 2BrF5, Br2 plus 5F2, 2BrF5. Okay, here fluorine you have taken in excess. Now I am telling you about properties. Okay, some properties of interhalogen compounds. Now I am telling you. First type, I told you different types: X, X-1, X, X-3, X, X-5, X, X-7. Then now you know that this halogen, this members are fluorine, chlorine, bromine, iodine. Hence obviously X, X-1, they can form different compound with different members. Then I am giving the examples of X, X-1, X, X-1. X, X-1 means ClF, BrF, IF, BrCl, ICl. Whatever possibility is there, you can write. But if difference of electronegativity is more, possibility will be more for the formation of interhalogen compound. More the differences of electronegativity, more the possibilities. Okay, less differences means less possibilities. Okay, then ClF. Then now we can see chlorine and fluorine. Differences are there in electronegativity, that's why it is making ClF. Then chlorine fluoride. This is a colorless gas. And BrF also can form bromine and fluorine. Differences are there in electronegativity. Then BrF, bromine fluoride. It is a pale brown gas. Question is asked. You give importance for the physical state, whether it is a solid, liquid or gas, and also color. Okay, question is asked only in this way. Now IF, iodine fluoride. Then this is actually I and F. Then it is forming iodine fluoride, and Actually, it is found in less quantity, detected spectroscopically. By a spectroscope, it was detected. Okay, and this BRCl now is also forming BRCl. Then bromine and chlorine, again differences there in electronegativity. It is forming BRCl. This is actually gas. And again it is forming ICl, iodine chloride. Its color is ruby red solid. It is solid. ICl is a solid alpha form. Then alpha form, it is called ruby red solid. Ruby red solid, it is alpha form. And other is beta form, that is a brown red solid. Both are solid, red solid, but one is ruby red solid, other is brown red solid. Then brown red solid is called beta form, and ruby red solid is called alpha form. And IBR, next compound is IBR. This is a black solid. Black solid. Then now I told you type 1, X dash 1. Now come to the X dash 3, second type. Total 3 types, 4 types are there. X dash 1, X dash 3, X dash 5, and X dash 7. And reason you are understanding, all 1, 3, 7, all odd. 1, 3, 5, 7, all odd are oxidation state. 1, 3, 5, 7 is showing oxidation state. Then second category, X dash 3. Then its various compounds are there. ClF3, BrF3, IF3, ICl3. Okay, but before this I want to tell you these things. I told you IF, but this is very unstable. More about IF. This is very unstable. And other I told you about the BRCl. Then BRCl is a gas, but pure solid is known at room temperature. Okay, this I told you more. This I told more about the this IF and BRCl. Now come to the second category, X dash 3. X dash 3. Example is ClF3, BrF3, IF3, and ICl3. Correct? Then now this physical state I am telling you and color. Then ClF3, chlorine trifluoride. It is a colorless gas, and its structure is bent T-shaped, just like a T you are writing, that type of shape, bent, B-E-N-T, bent T-shaped. Okay, and BrF3, bromine. First one was chlorine trifluoride, now bromine trifluoride. Then this is the yellow-green liquid. Always remember, question is asked. Yellow-green liquid, BrF3. And it is also, a structure is same, bent T-shaped. And IF3 now, iodine trifluoride, chlorine trifluoride, bromine trifluoride, now iodine trifluoride. This is the yellow powder. powder, means solid only. And its structure is again bent T-shaped. Bent T-shaped. Then all three you have seen, shape is bent TF. Now one more, ICl3. ICl3. Now all were what I discussed, that was the F3. ClF3, BrF3, IF3. Now ICl3. ICl3. This is a solid, orange solid, and its shape is again same way, vent T-shaped. Vent T-shaped. Okay, and actually it will dimerize. It dimerizes, and it can tell you will get it as a I2Cl6 also. ICl3 can dimerize, and it can give I2Cl6. Now come to the third type, X-5. Then again with fluorine chances are maximum. Then IF5, BR5, Cl F5. IR F5, BR F5, Cl F5. Then here oxidation state is +5. Then IF5, iodine pentafluoride. This is the colorless gas. This is the colorless gas, but solid below 77 Kelvin. That temperature will go in minus. IF7, iodine pentafluoride is colorless gas, but solid below 77 Kelvin. And its structure is a square pyramidal. A square pyramidal. Structure and color both is asked. State is also asked. Then IF7 is a colorless gas but solid below 77 Kelvin. Now BrF5, bromine pentafluoride. It is a colorless liquid. Colorless liquid. Okay. And its structure is again same way, a square pyramidal. And ClF5, chlorine pentafluoride. It is again liquid, colorless liquid. BrF5 and ClF5 both are colorless liquid. Okay, and its structure is again same, a square pyramidal. A square pyramidal means all IF5, BrF5, ClF5 all are a square pyramidal. All three are a square pyramidal. And out of three, last two means BrF5, ClF5 is a colorless liquid, and first one, that is IF5, is a colorless gas but solid below 77 Kelvin. Now X-7 means fourth category and last category. X-7, its example is IF7, iodine heptafluoride. IF7, iodine heptafluoride. This is a gas, actually colorless gas, and its structure is pentagonal pyramidal. Always remember, only one is there, only one. IF7, iodine pentafluoride, is colorless gas and its structure is pentagonal bipyramidal. Okay. Then this I have discussed about interhalogen compounds. Okay. Now little more I want to tell. These means interhalogen compounds I am talking about. These are all covalent molecule and are diamagnetic in nature. Question is asked. Remember, these are all covalent molecule and are diamagnetic in nature. They are volatile solids or liquids at 298 Kelvin. Exception is there, except ClF, which is a gas. Again I am telling you, halogens, interhalogens compounds I am talking about. They are volatile solid or liquids at 298 Kelvin. Exception is except ClF, remember, which is a gas, and all are solid or liquid. ClF is a gas, exception. Their interhalogen compounds I am talking about, their physical properties are intermediate between those of constituent halogen. Their physical properties are in the middle, or you can tell intermediate between those of constituent halogen atoms. Exception is there. Exception is in melting point and boiling point, except that their melting and boiling points are little higher than expected. Melting and boiling points are more than expected, and other physical properties are in the middle or intermediate of two elements what they are joining. Their chemical reactions are very less. Their chemical reaction can be compared with individual halogens. In general, interhalogen compounds are more reactive than halogen. Exception is fluorine. Question is asked. Listen again. In general, interhalogen compounds are more reactive than halogen. Exception is fluorine. Why it is like that? This is because X bond, X dash bond, like Cl, Br, I bonds in the interhalogen I am talking about. In interhalogen, bonds are weaker than XX bonds in halogen. Like Cl, Br, I, that bond is stronger. But interhalogen bonds between interhalogens compounds are weaker than halogen. That's why halogens are more reactive than interhalogens are more reactive than halogen. Exception is fluorine, FF, which is that is a more bond is very weak, weaker than interhalogen. That's why it is an exception. Okay, FF is more reactive than interhalogens. Question is asked. All interhalogen compounds undergo hydrolysis, giving halide ion. Halide ion it will give. Now condition I am telling you. All these interhalogen compound undergo hydrolysis. Means H2O will break in H and OH. That is called hydrolysis. All these undergo hydrolysis, giving halide ion. It will give halide ion derived from the smaller halogen. And a hypohalite. Okay. Then now condition start. When X dash, that time it will give this thing hypohalite. Okay, it will give hypohalite when X dash is there, and halite when X dash 3 is there, X dash 3 is there, and halate when X dash 5 is there, and perhalate when X7 is there. Okay. Then there are actually anion derived from the larger halogen. Okay, these are anion, and they means I am talking about first I told you hypohalite, then hypo from X dash, halite X 3, and halate halate X 5, and perhalate X 7. These are anion derived from the larger halogen. Okay, larger halogen will give anion, a smaller will give cation. X reaction, general reaction I am telling you, X dash plus H2O, it will give HX. HX means halide plus HOX, hypohalite. XX dash plus H2O, HX dash plus HOX, HX dash plus HOX. Okay, this is general. Their molecular structures are very interesting, okay, which can be explained on the basis of VSEPR theory, valence shell electron pair repulsion theory. Their structures are very interesting and can be explained on the basis of VSEPR theory, valence shell electron pair repulsion theory. The XX3 compound have the bent T shape. Already I told you. XX5 compound a square pyramidal, and IF7 has pentagonal pyramidal structure. Okay, already I have discussed. Okay, then just I will give one explanation. I want to give one explanation because in examination one question was asked. Question was like that: deduce the molecular shape of BRF5 on the basis of VSEPR theory. Question was asked: deduce the molecular shape of BRF3 on the basis of VSEPR theory. Then its structure, you know that bromine will have 7 electrons in outermost orbit, that you know. Then 3 out of 7, 3 they will make bond with fluorine, BRF3, then 3 single bond. Okay, and out of this 3, 2 bond BRF will be a straight. Roughly a straight, not 100% 180 degree, maybe 178 like that. BRF and BRF, you can say roughly 180, little less, or maybe 178, 176, little less. Okay, and third bond will be down, BRF, just like a T. T you are writing a T letter, same way. BRF one side, left side, one BRF right side, and down perpendicular BRF. And then now only 3 electrons used up, 4 electrons are remaining. Then this bromine will have 2 lone pair of electron. Okay, then 2 plus 2, 4 electron, 2 pair, 1 pair plus 1 pair, 2 pair electron will be there on bromine. Then this is actually a structure of BF3. Now I told you that this one BRF bond is little tilted, bent, little bent T-shaped, I told you, little. Why it is like that? and between this two lone pair are there, then these two lone pair will again they will make distance. Now you know that between the lone pair and lone pair repulsion will be more. Repulsion will be more. That's why they will make distance. Then lone pair repulsion is more according to BSE-PR theory. And after that, lone pair and bond pair. Bond pair means ordinary bond you are making, 2 electrons are required. Then there will be also repulsion between lone pair and bond pair. That's why one bond will be bent, little that BRF bond will be little bent due to this repulsion. Lone pair and bond pair repulsion is less than bond pair and bond pair. Now again you can see bond pair repulsion will be less than lone pair and bond pair. Always remember, lone pair is greater, repulsion is greater than lone pair and bond pair, and lone pair bond pair repulsion is greater than bond pair means bond pair repulsion will be very less. That's why it is called BRF3 is called bent T structure. Bent T structure, all three structure I told you, all are bent T structure. Okay. Then this I have main thing I have discussed. Now I am telling little more. The central atom bromine has 7 electrons in the valence shell. The 3 of these will form electron pair bonds with 3 fluorine atoms, leaving behind 4 electrons. Thus, there are 3 bond pair and 2 lone pair. According to BSEPR theory, these will occupy the corner of trigonal bipyramidal. The 2 lone pair will occupy the equatorial position. Remember, 2 lone pair will occupy the equatorial position to minimize the lone pair and the bond pair repulsions, which are greater than the bond pair repulsion. In addition, the axial fluorine atoms means bond between bromine and fluorine, that is called axial, and this bond between this thing lone pair that is called equatorial. Okay, 2 lone pairs will occupy the equatorial position. Bond they are not making, but position is equatorial. And B, R and F, that bonds is called axial. The axial fluorine atom will be bent towards the equatorial fluorine in order to minimize the lone pair repulsion. The shape will be that of slightly bent T shaped, what you are telling. Okay. Then now I am telling usage, application of interhalogen compounds. These compounds can be used as a non-aqueous solvent. Remember, water is the universal solvent. Water is the universal solvent. Almost all material will dissolve in water. But some reaction will not take place in water. As for example, this thing, lithium reacts violently with water. Hence, reaction can't take place with water or in water. Then for that purpose, non-aqueous solvent is required. Non-aqueous solvent means water should not be there. Then that time where then solvent may be non-aqueous also. Non-aqueous. Water is one type, major. But non-aqueous solvent, that is this iodine interhalogen compound can be used as a non-aqueous solvent. Okay, first. Now second use, interhalogen compounds are very useful fluorinating agents, means it can supply fluorine. ClF3 and BrF3 are used for the production of UF6 in the enrichment of 235 uranium. In nuclear reactor, actually there it is used because uranium will react with fluorine and it will form a compound UF6. That's why if during the nuclear reaction this uranium 235 we are getting, that can be separated when it will make compound UF6. Then this ClF3, BrF3, they will supply fluorine and it will form UF6 compound. Then its reaction is very simple. Uranium is solid, uranium plus 3 ClF3. It will form UF6 plus 3 ClF. Then ClF is gas, Then these are the limited use of interhalogen compound. Now I am stopping only here. Next class I will start group 18 elements. Thank you.